All right, now let's talk about box plots. So box plots are another common way to visualize data. And here is an example of a box plot. So similar to the histogram, a box plot is often used to look at a single variable. However, multiple box plots can be plotted side by side to compare across groups. And like the histogram, box plots are intended for continuous variables. And here again, the purpose is to be able to display the distribution or the shape of the variable. So now the y-axis, or the vertical axis, is actually the variable's value. So going back to that table 1 from the closed randomized trial example that we spoke about before, recall that here we're looking at continuous variables again. And the box plot now is instead of displaying the full distribution like the histogram, it's displaying some specific points from this table 1. So the bottom line here, highlighted in green with this dashed line, represents the 25th percentile of the data. And so that means that 25% of the data fall below this point. And then this line in the middle of a box plot, that represents the median or the middle point of the data. And the box plot itself makes up 50% of the data, so from the 25th percentile up to the 75th. So that top line of the box plot is going to be the 75th percentile. I've highlighted here with that green dashed line. And that means that 25% of the data fall above this point and 75% of the data fall below it. Then the box plot has two lines that extend on either side of the box. And these often represent 1.5 times the interquartile range. So the interquartile range is from the 25th percentile to the 75th percentile. And so that will represent 1.5 times that. Or sometimes it'll be the minimum and maximum values of the variable, whichever one of those two is smaller. And so if 1.5 times the interquartile range is smaller than the minimum or maximum, then the remaining points above this are often drawn as individual dots. And so these are sometimes identified as potential outliers. It's important to note that these values, while they're outside of this pre-specified range, they might be entirely accurate and appropriate points to include. So just because sometimes people talk about them as potential outliers doesn't necessarily mean that they ought to be not included in the study. But they can be really crucial to look at because maybe there's something different about participants that have these far off values that needs to be noted in the study itself. So like the histogram, there are a couple of pitfalls to be aware of when you're evaluating a box plot. And the first is because box plots, they're essentially visual depictions of summary measures. So, the table 1 described those summary measures, the median, the 25th percentile, and the 75th percentile, as well as the minimum and maximum in the closed trial case. And a box plot really doesn't show you much more than that. It just shows it in a visual way. And so because of that, they can mask skewed data. For example, this plot doesn't give a lot of information about what the underlying data actually look like. And so here I've added those data points themselves, and notice that they actually clump around two values, around the 75th percentile and the 25th percentile. And so without these points, without seeing the data points themselves, just looking at the plot, there's no way to know, what that data actually looks like. And it could give the false illusion that there are points throughout the entire range of that blue box, when in reality, they just fall really in two places. So this kind of gets back to that principle of good statistical graphics, that it actually reveals the data itself. It shows that data instead of just being a depiction that could potentially hide it. And kind of in a similar vein, the second potential pitfall of a box plot is that it can mask the underlying sample size. And so from just looking at this plot, there's no way to assess how many points are actually being evaluated. And so again, I can plot those actual data points. I can overlay them on this box plot. And notice that this plot was actually created from only 10 points. And so when looking at this box plot, there was no way that I could have known that there were really only 10 points that created this plot. And so it can kind of give the false illusion like there's a lot of data when there really isn't. So when evaluating a box plot, it's really important to gather information like the sample size from the text of the article in order to get the full picture of the variable that's being assessed. Okay, so here's a real example. This example studies the impact of case area targeted interventions in response to cholera. And so this box plot here shows 3 different interventions: antibiotics, an oral cholera vaccine, and point of use water treatment, started at 3 different times: early, peak, and late. And so early here is depicted in the blue, peak is in the red, and late is in the purple. And so from this, we can glean that the point of use water treatment and the oral cholera vaccine led to faster extinction of outbreaks than antibiotics. And we know that because of where those boxes lie in comparison to each other. And we can also see that the early interventions reduced the epidemic faster than the peak or the late interventions. And we can see that because the blue boxes for the early intervention are always a little bit above the red and the purple boxes for the peak and the late intervention. So you can read more about this article in PLOS Medicine if you're interested, but there's an example of a box plot out there in the wild.